We now discuss the solution of a problem from the section Statistics. The problem is based on the concepts of standard deviation. This problem has appeared in Joint Entrance Examination Main held on 25th July 2021 in the second shift. The problem is the first of the two samples in a group has 100 items with mean 15 and standard deviation 3. If the whole group has 250 items with mean 15.6 and standard deviation under the square root of 13.44, then the standard deviation of the second sample is, 4 options are given to us. Option 1, 5. Option 2, 8. Option 3, 6. Option 4, 4. Let's now recall some of the concepts that we require to answer this question. First, mean. If x1, x2, xn are n observations, then the mean is denoted by x bar, and it is given by x bar is equal to x1 plus x2 plus etc. plus xn by n. That is sigma I is equal to 1 to n xi by n. And we require the notion of combined mean. If x1 bar, x2 bar, etc., xk bar are the means of k sets of sizes n1, n2, nk respectively, then their combined mean is given by x1 k bar. So k denotes k sets and their means. x1 k bar denotes the combined mean of the means x1 bar, x2 bar, xk bar of k sets of sizes n1, n2, nk, and it is given by n1 x1 bar plus n2 x2 bar plus etc. plus nk xk bar by n1 plus n2 plus etc. plus nk. Standard deviation denoted by SDE, and it is denoted by sigma. If x1, x2, xn are n observations, then its standard deviation is given by sigma is equal to under the square root of sigma I is equal to 1 to n, the summation sigma I is equal to 1 to n of xi minus x bar whole square by n, that is also given by under the square root of 1 by n summation sigma I is equal to 1 to n xi square minus x bar whole square. The variance is defined as the square of the standard deviation, that is sigma square. Here we have a formula for a combined variance. Two different series having n1, n2 observations and whose corresponding means and variances are, the means are x1 bar, x2 bar, and their variances are sigma 1 square, sigma 2 square, then their combined variance sigma square is given by n1 sigma 1 square plus n2 sigma 2 square plus n1 d1 square plus n2 d2 square by n1 plus n2, where D1 is x1 bar, the mean, minus x12 bar, the combined mean. D2 is equal to x2 bar minus x12 bar, that is and x12 bar is given by n1 x1 bar plus n2 x2 bar by n1 plus n2. This formula we will be using in our answering the question. Let's get into the problem. We make a table. We have a group G with n is equal to 250 items. Mean x bar is equal to 15.6 and standard deviation sigma is under the square root of 13.44. This mean is the combined mean and SD is the combined SD. And this is, so under group G, n 250 items, mean, their mean is x bar is equal to 15.6 and it is combined. Standard deviation sigma is under the square root of 13.44 and it is a combined one. G has two samples, say A and B. The first sample A has n1 is equal to 100 items. Mean is given by x1 bar is equal to 15 and standard deviation sigma 1 is equal to 3. And the second sample B has n2 items. We have to find. Its mean is x2 bar. We have to find. And the question is, we have to find the standard deviation of the second sample, that is sigma 2 is how much. That is the question. So now we continue. So that is the table what we have. And now n, the total number of items is 250 and we have two samples A and B of sizes n1 and n2. Therefore, n is equal to n1 plus n2. That implies n is 250 is equal to n1 is 100 plus n2. That will imply n2 is 150. So this n2 is 150. Now, we now find x2 bar, the mean of the sample B. We have x bar, that is the combined mean of the means of A and B, and that is given by n1 x1 bar plus n2 x2 bar by n1 plus n2. And in this, all quantities are known except x2 bar. So substitute x bar is 15.6 is equal to n1 100 into x1 bar 15 plus n2 150 into x2 bar is unknown by n1 plus n2 is 250. We cross multiply, we will get 15.6 into 250 is equal to 1500 plus 150 into x2. And simplifying, we will get 150 x2 bar is equal to 2400. That will give you x2 bar is equal to 2400 by 150, that is 16. So we have n2 150, x2 bar is 16. Let's put that in the table. So that's the new table now. So n2 is filled, x2 bar is filled, and sigma 2 is to be found. And the combined sigma is known, sigma 1 is known, and we can use that formula. Let's see. And that's our table. And we use now, we have sigma square, that is the combined variance, is equal to n1 sigma 1 square, the variance of A, n2 sigma 2 square, sigma 2 square is variance of B, plus n1 d1 square plus n2 d2 square by n1 plus n2, where d1 is x1 bar, the mean of A, minus x bar, the combined mean, and d2 is equal to x2 bar minus x bar. That is, d1 is x1 bar, that is 15, and x bar is 15.6. So that will be minus 0.6. d2 is x2 bar, that is 16, minus combined mean, that is 15.6, that is 0.4. So substitute all items in this. So sigma square is known, everything is known except sigma 2 square. So we write down sigma square is 13.44 is equal to n1 into sigma 1 square. n1 is 100 into sigma 1 square, that is 3 square, that is 100 into 900, plus 150 into sigma 2 square, 150 into sigma 2 square, plus n1 into d1 0.6 square, plus n2 150 into d2 square 0.4 square by n1 plus n2, that is 100 plus 150, that is 250, and that will be equal to 900 plus 150 into sigma 2 square, plus this is 36 plus this is 24 by 250, and that is, when simplified, will be 960 plus 152 into sigma 2 square by 250. Cross multiplying, we will get 960 plus 150 into sigma 2 square is equal to 13.44 into 250, and when multiplied you will get 3360, and that will give you 150 into sigma 2 square is 3360 minus 960, that is 2400, and sigma 2 square is equal to 2400 by 150, that is 16, and sigma 2 is 4. That is the standard deviation of the second sample. So what are our options? And our answer, sigma 2 is equal to 4, appears against option 4. Therefore, our answer is option 4. So that is by the method 1, where we have used this formula. And some of you may not be using this formula. Then we will use only the definition of the standard deviation and find out sigma 2 in the method 2. And n2 is 150, x2 bar is 16, up to that you have to do. From there, the second method will start. Method 2. So this is what we have, and for convenience, the items are indexed. The items of G are indexed as x1, x2, etc., x250, and the items of A are the first 100 items, that is xi, I is equal to 1 to 100, and the items of B are the next 150 items, that is the set of all xi, I is equal to 101 to 250. So the items are indexed here for convenience. And now let's take down the group G, and we have sigma. What is sigma? Is the combined standard deviation that is given to be under the square root of 13.44. and its square, that is variance, is 13.44. And we use the formula, and sigma is under the square root of this, and sigma square is equal to 1 by n into summation I is equal to 1 to n xi square minus x bar square is equal to 13.44, and n is 250, and x bar is known, and this summation I is equal to 1 to n is 250 xi square will get, that is 1 by 250 summation I is equal to 1 to 250 into xi square minus 15.6 whole square is equal to 13.44. Send this 15.6 square to the other side, and now cross multiply, will get sigma I is equal to 1 to 250 xi square is 250 into, in brackets, 13.44 plus 15.6 whole square. Simplifying, we will get 64,200. So thus we got the sum of the squares of the items of the group A, that is sigma I is equal to 1 to 250 xi square is 64,200. Likewise, for the sample A also we can do, and we will do that in the next slide. So we have the table, and the sample A is here, and for the sample A, and we know sigma 1 square, that is 3 square, that is 9, and the formula is 1 by n1 into sigma I is equal to 1 to n1 xi square minus x1 bar square. And in this, all are known except this sigma I is equal to 1 to n1 xi square. So that we will continue. We will compute. This will imply 1 by n1 is 100 into sigma I is equal to 1 to 100 xi square minus x1 bar, that is 15 square, is equal to 3 square. 3 square is 9, 15 square is 225. When sent to that side, we will get 234, and send this 100 to the other side. So that will be sigma I is equal to 1 to 100 xi square is equal to 234 into 100, that is 23,400. We got it. So for the sample A, we got this. Now for the sample B, we can also write sigma I is equal to 101 to 250 of xi square. We can now find out. Now got it. Now that the sample B has come here, and for the sample B, sigma I is equal to 101 to 250 xi square is equal to sigma I is equal to 1 to 250 xi square. From that, subtract minus sigma I is equal to 1 to 100 xi square. That is, this one is 64,200 and this one is 23,400, and we got 40,800. So we got the sigma I is equal to 101 to 250 xi square. We got this as 40,800. Now we can very easily calculate now sigma 2 square using the formula of SD, standard deviation. For the group, entire group G, we have sigma I is equal to 1 to 250 xi square is 64,200. For sample A, sigma I is equal to 1 to 100 xi square is 23,400. And for the sample B, we have just now computed I is equal to 101 to 250 xi square is 40,800, and x2 bar is 16. And now sigma 2, that is the standard deviation of the sample B, is equal to under the square root of 1 by n2, number of items, into summation I is equal to 101 to 250 xi square minus x bar square. X bar square means here in this case x2 bar square. So that we will write. We'll write x2 bar square. And 1 by 150, this is known, everything is known. So this is 1 by under the square root of 1 by 150 into summation I is equal to 101 to 250 xi square is 40,800 multiplied by minus 16 square, and that is under the square root of 272 minus 256 simplified, and that is equal to under the square root of 16, that is equal to 4. So in this we have not made use of any combined variance formula, and we have just used the definition of the standard deviation only. The standard deviation of the group G, the standard deviation of the group A. From these two, we have computed the standard deviation of the sample B. Sample A, not the group A, sample A and sample B. Now let's look at our options. The 4 options are here, and our answer sigma 2 SD of sample B is 4, appears against option 4. Therefore, our answer is option 4. So that is the discussion of the solution of the problem from the statistics based on standard deviation. I have shown you 2 methods. In the method 1, I made use of the combined variance formula. In the method 2, I have just made use of the definition of the standard deviation. So that is the solution of that problem. I hope that you have understood the solution and go on working out some more problems based on standard deviation and variance of the given data. I wish you all the best. Thank you.